All right, so what we're going to do in this video is just go over the three basic types of nuclear decay. Now remember, I've said many times that there's a lot more out there, but we're just going to cover the main three, which are alpha, beta, and gamma. Remember, alpha's got this, there you go. Alpha's got this little funny sign. This is alpha, and basically these are little helium nuclei. They're positively charged. There's 2 protons, and there's 4 total things that make up this nucleus, and 2 of them are, of course, are the protons, and we've got 2 neutrons. Notice there's no electrons, so these guys are positively charged. Beta particles, remember beta particles, 1 neutron said, I'll just take one for the team. I'll become 1 proton that stays in the nucleus and 1 little electron that pops out at high speed. Now this 1 electron, of course, has to be confusing. You can't just write 1e. It's got to be 0 mass, -1, because remember positive 1 would just be a proton, but the opposite of that is -1. And then we got to put this funny looking B sign there. So we've got alpha, beta, and then gamma is that funny looking Y, and this is just energy. This isn't a particle at all. This is just energy that comes out, and we usually put a 0 and a 0 there to show that it's not a proton, it's not an electron, and it has no mass whatsoever, so it's just energy. All right, we got alpha decay here. Let's look at an actual symbol or equation for alpha decay, and let's look at the general trends. Over here, you notice that 222 goes down to 218. That means 4 particles come out of the nucleus. 86 goes down to 84. The number of protons, remember atomic number is number of protons. Protons goes down by 2. That means 2 protons come out. So here they are. We write a little helium symbol here, or we could write the alpha symbol. The bottom number is going to have a 2. Top number is going to have a 4. 4 particles came out. 2 of them are protons. Therefore, it ejected in a little helium nucleus. This is the general symbol or equation that you'll always see for alpha. The mass number goes down by 4. The atomic number goes down by 2. We write the 4 and the 2 over here. And if you do the math, everything adds back up. 4 plus 218 equals 222. 2 plus 84 equals 86. Now, beta decay. Beta, remember, one of these neutrons takes one for the team. So of the 239 protons and neutrons, one of these neutrons says, I'll turn into a proton. So neutron goes down, proton goes up. Overall, this is a wash. So the mass number stays the same, hence the 0. However, we got 1 more proton out of the deal here. Remember, there weren't enough protons and there were too many neutrons. This guy was unstable to begin with. So the protons went up, 93 up to 94. Remember, this doesn't change because the protons goes down, or the neutrons goes down, but the protons goes up. So this stays the same, but the protons goes up, and that's reflected here. This changes our element. So we look at our handy-dandy periodic table, and we figure out that it's not Neptunium anymore, but it's plutonium. So we show that the identity has changed, protons increased, and then here's our little high-speed electron. If we put a 1 here, that means it's a proton. But a -1 tells us the opposite. What's the opposite of a proton? An electron. So this is our electron, and that funny looking B tells us it's what we call a beta particle. And this guy is lots of energy. It pops out of the nucleus because it doesn't belong in the nucleus with these guys. It comes out, it's very light, pretty much has no mass, so it travels very far, way farther than these guys. These guys are pretty big and bulky compared to this high-speed little electron. So it has more penetrating power, and it can do more damage than alpha decay. And finally, we have gamma. Gamma is the easiest one out there because nothing changes, because no particles are emitted. 0 mass, 0 for an atomic number, just this funny looking Y, and that represents this energy, which has way more penetrating power and can travel much farther distances than either alpha or beta. So this one can do the most damage, and this is the one we have to be most concerned with. But in terms of writing equations, you gotta love gamma decay because nothing changes. All right, now what if you were given an equation like this? And you have to fill in the blanks here. We see that we start with 214 over 83 bismuth, and this is released. This should signal to you that this is beta decay. So you should be able to label this as beta decay. You should know that the neutron turns into a proton and an electron. The proton stays in the nucleus, so 83 is going to go up to 84. But the overall change is basically nothing. The neutron went down, but the proton went up. So 214 is going to be our final mass in there. And then we have to look at a periodic table. What's number 84? PO. So this B gave us a symbol or a signal that it was beta. You should know that in beta decay, a neutron turns into a proton and electron. Protons go up, electrons pop out. There's our electron popping out. And then we can use that information, protons going up one, to figure out what new element. 83 turns into 84. Look at your periodic table, figure out that it's polonium. Top number doesn't change because the neutron going down and the proton going up cancels each other out. All right, let's look at this guy here. Now we see that our mass number goes down by 4 and our atomic number goes down by 2. That should signal to you that it's alpha decay. Alpha decay. So this top number is a 4, bottom number is a 2, and it's always HE, or you could put the little alpha symbol there. I don't care which one you put, but that's what you should be filling in the blank with. And again, looking at the atomic number and the mass number gave me the clue that it's alpha decay. All right, the next one. I got 227 staying 227, so the top number doesn't change. So I'll put a 0 there. 89 goes up to 90, so it looks like somehow this gained a proton. So that should signal to you that this is beta. Anytime it gains a proton, it's beta. Why? Because one of these neutrons turns into a proton and an electron. So the neutrons goes down, but the proton goes up, meaning there's no overall change in the nucleus in terms of mass number, but the atomic number goes up 1. So there's our change in protons. 90, look down the periodic table, we got a new element here, and what's missing is the little electron that pops out along with beta decay. So you should know that anytime beta decay occurs, there should be an electron popping out, high-speed electron. Now let's look at the next one. The next one, I see the symbol for gamma. And I know gammas are easy because nothing changes, 0, 0. So I just rewrite it, 137.56, BA, nothing changes at all, but I do know that lots of energy comes out. And that energy could be dangerous, especially to human cells. All right, now, what if I give you nothing but the type of decay that occurs? I tell you this is alpha. Alpha to you should immediately pop up the 4 over 2 HE in your head. So this is going to be emitted. In alpha decay, this little guy is emitted. That means 185 minus the 4 leaves me with 181. And then 79 minus 2 is 77. And I don't know what element this is off the top of my head because I don't have a periodic table. So I'm going to look one up. And I got IR. Always keep a periodic table with you. All right, so this is the new element that's formed during alpha decay. My mass number goes down 4 and my atomic number goes down 2. This is important because this is going to tell me the identity of my isotope. Beta decay. All right, I give you nothing here but what you start with. And what you start with is wrong. This should be a 6. Sorry about that. All right, so 14 over 6. Remember, during beta decay, one little neutron says, all right, I know we have a problem. There's too many neutrons, not enough protons. I'm going to turn into a proton. I'll take one for the team. That proton sticks around the nucleus. So 6 goes up to 7. The overall change is a wash. So it's 14. We look on the periodic table. What's element number 7? It's nitrogen. And then through beta decay, you should know a little electron pops out. 0, -1 with a B. And finally, gamma decay. Gamma decay is awesome because nothing changes. 152, 66, dy. Some energy is released from the nucleus. So we write 0, 0 with the funny looking gamma symbol. And we know that this is energy And we know that this can do some serious damage when it's emitted. So that's gamma decay. So all in all, you should be able to recognize a symbol and decide what that means. So if you see this beta symbol, you should know that a neutron has turned into a proton and an electron. The electron is this here that's popping out, and the proton sticks around and makes the atomic number go up by 1. If you see this symbol, you should know that nothing is changing except a serious amount of energy is being released. And if you see this symbol, you should know that the 4 particles, 2 protons, 2 neutrons are popping out, and 2 of those protons are going to be in this nucleus, making it helium.